welcome. Thanks for having me. Reqs to Reqs. Yes, the talk is about making ASVS accessible to developers through the power of graphs and LLMs. And that's tons of buzzwords to start with. So first of all, who knows ASVS? Who is using ASVS? Nobody? No worries. I'll explain. Who is using Reqs? Who knows what Reqs are? A bit more. Okay, I'll also explain about Reqs. So a little bit about me. I know half of you. That's that's great to have an audience. I know half of the people. I've started as a software developer, which I think helps a lot in my current role in AppSec lead. Then I was a pen tester. This is how I know you guys. And now I'm working for a company that is graph database. As an application security lead, we are a small team, 2 people, to about 250 developers. Lots of fun. The technical stack has everything you probably ever heard of. So this is the plan for the talk, and hopefully there will be time for questions in the end. Well, I'm sure there will be time for questions. And this is a journey that our security team went on. So hopefully it's quite easy to follow for everyone. I'm not data scientist, I'm not machine learning specialist. Hopefully it's on the level that everyone can follow, and it's a journey. It's not a shiny product at the end of it. Hopefully people can learn and play with it in their own environment. So first of all, what is ASVS? I promised to explain. It's an OWASP project. Everyone knows OWASP, right? It's an OWASP project. It's Application Security Verification Standard, and it provides a basis for testing web applications. It's expanding outside of web applications, but still web applications is a lot of software in this world, and it has a lot of bugs and security gotchas, and it's really good to have security requirements for it. If you worked in a software company, you probably know it's quite hard to get security requirements, and especially good security requirements. If you work in a decent place that cares about its users, you probably get functional security requirements, things like security features. But security of software is not only about security features, it's about attack surface of every feature. We want every feature to be secure. And these are what's called non-functional requirements, and these are really hard to get out of your PM or product owner, whoever gives requirements in your environment. Sometimes you get like really useless ones. This product must be secure. That's not very actionable. So this is ASVS, where it can be really helpful with getting actionable security requirements. So let's look a bit more. What is ASVS? It has 14 chapters, 14 sections. Each one deals with an area of security that's relevant to web applications. And you can use it in a variety of ways. You can use it to tailor your secure coding checklist, if you have one. If you don't have one, you should get one. So chapter 1 is all about architecture, so you can use this standard to get architecture security guidance. You can use it for deriving automated or even not automated unit and acceptance tests, because sometimes it's too late for requirements. The software already exists and we just need to test it. You can use it even to guide your training. And if you don't build software, you probably buy software. How do you evaluate the security of the software you buy? It can be useful for that as well. What else I like about this standard, it fits agile development. Okay, forget agile, modern development life cycles. It can be very bite-sized. You can do self-evaluation. You can understand your current state. And it has 3 levels. So level 1 is very basic. It's probably only good for brochureware. Level 2 is good for majority of applications. And level 3 is for highly specialized things like medical devices, things where you really need to pay attention to your security requirements. So you can find your level, you can find what's missing, and you can build a program of incremental step-by-step improvements. It's such a marvelous standard, in my opinion, why it's not more famous, right? Everybody knows OWASP Top 10. Who doesn't know OWASP Top 10? It's another OWASP project that talks about 10 most problematic security mistakes you can make in your software. But it's probably the most famous OWASP project. Why this one is less famous? Because you can have too much of a good thing. There are 280 requirements in this standard, and that's just too much. So this is an example of what it looks like. So chapter 3 has multiple sections. Each section has multiple requirements. The 3 levels that I've mentioned. It mapped to CWEs, Common Weakness Enumeration. It mapped to NIST, which is very useful standard that lots of organizations follow. So it makes sense, it's mapped to NIST. But there are a lot of them. And that's the problem. We said most organizations work in agile, iterative, lean, whatever, quick, modern life cycles. And we want requirements that are relevant to the current feature. And we want advice that is relevant to the current state, right? Sometimes you need requirements, sometimes you need coding guidance, and sometimes you need tests because software is already written and we're still trying to secure it. So how to use this standard in a focused way to give developers what they need, when they need it, in a relevant form. The usual advice is called tailor it. So if you watch this presentation, is by Josh Grossman, one of the leaders of this project. It's an excellent presentation, Sustainable ASVS. He talks about tailoring it, figure out what makes no sense in your context, get rid of these requirements, tailor it to your organization. And it's not quite easy. So like this code is tailored, but still looks quite too big for me. We start with one of our champions, and we went through the standard, and he managed to reduce from 280 requirements to 160, getting rid of what's not relevant for us. So that's much better, but that's still too much. We cannot expect for every feature, for every piece of work, we cannot ask developers to go through this list and figure out what's relevant and how to apply it and how to test for it. It's just not practical. I mean, we can ask, but we're not likely to hear enthusiastic yes. And also how it would look in practical terms. It feels like another spreadsheet is coming. And no one needs another spreadsheet in their lives. Surely we can do better. So this is our journey trying to make it better. So our first attempt was, let's try LLMs. I have a feature. I'm asking ChatGPT which ASVS requirements are relevant for my feature. And you can check it's hallucinating. The numbers that it tells, the text that it assigns to these numbers, it's not true. If you open ASVS standard, it's hallucination. So before I even start checking, are these requirements really relevant for my feature, the requirements themselves are garbage. So we tried to fight this problem. with prompt engineering. Yes, it didn't work. So that was first step on our journey, thinking ChatGPT will not help us here. Right. So I work for Neo4j. It's a graph database company. So graphs are kind of top on my mind. But even without it, I think it's pretty easy to spot that ASVS is a graphy data. So we have 14 chapters. Each chapter has multiple sections. Each section has multiple requirements. It's a tree. Not a binary tree that most people know and love, but a tree nevertheless, and the tree is a graph. So that's good. What does it mean? How can we use this property? How we can get focused requirements that are relevant to our feature? I've imported SVS to Neo4j database. I will explain how I've done it, but for now, let's gloss over the import bit. And this is what it looks like. The purple bits are chapters, and the gray ones are sections, and the yellow requirements. And the requirements are in different size because I chose to show level 3 as bigger circles, just to show there is usually more work to get to them. And you can tell me that's not a tree, that's a forest, true. Just to fit everything on one screen, I'm not showing the root nodes, that's standard. So that's one view, it's called hierarchical view. You can also have this kind of view where it pretends that nodes follow law of gravity. That's just apart from pretty visualization. That's the interesting bit, right? Nodes have properties. It's a property graph. Nodes have properties. And the most important property of requirement is this piece of text that describes what it's all about. And we can use this piece of text to calculate vector embedding on it and find requirements that are semantically similar to my feature description. And the architecture for this looks like that typically. So what we want user to ask a question, to say, I want to develop a feature that does this, like a couple of paragraphs, what you would put in your Jira ticket, for example. We want to use vector similarity to look up ASVS requirements that are similar enough to be relevant. And we want to feed what we looked up to LLM, and hopefully it will give us better answers. So when people talk about RAG means Retrieval-Augmented Generation. So you have generation tends to hallucinate. We want to augment it, to improve it, with retrieval of a relevant context from our database. So that's the plan. I'll do a little demo. All the tools are free in this repo, apart from you will need to bring your own key. By the way, it doesn't have to be OpenAI. It can be any other LLM to which you are happy to give your feature description. But it works out very, very cheap. So this is a little app that uses Streamlit, which is a super simple framework. What we have here is a couple of parameters. So by default, it will bring top 10 relevant requirements. Sometimes you have lots of relevant requirements. You probably want to increase it. And you have a cutoff for similarity. It gives you an example. So let's grab this example, feature description. We want to add some pay-per-view features in our SaaS product. Submit for requirements generation. What it does, it calculates vector embedding on this text. It goes to to our graph of ASVS requirements, picks the top 10 most semantically similar ones, and sends them as a context to an LLM. And now we have answers that are not hallucinations. The numbers match what is actually in ASVS standard, and they are actually reasonably relevant. So another thing I want to check is, does it just create busy work for developers because some features have no security significance? So sales will tell us, please make the buy me button bigger or change the colors or whatever. So I want to color some pixels red. That's my feature. I submit it for requirements generation. And I get, your feature description doesn't bring up any relevant ASVS requirements. Lucky you. So at least we know we don't create stupid work for developers with this little application. Let me try to go back to the presentation now. Right. So when we presented it with my colleague Alex, who half of you also know, last year in OWASP meetup, we said we have ideas for future development. We want to Dockerize this up. We want authentication so you can host it on your internal web. We want all sorts of things. And then we came back from the conference, as you do, and real work hits. And you think it feels like we are trying to build a product here and kind of vanity project, and we don't have time for that. And there are millions of startups who build LLM products probably better than us. That's not our core competency. So we didn't do these things. I've only done number 4, integrate with backlog tools. If you noticed in the demo, there was option, instead of typing your feature description, you could give a link to Trello card. And I only done it out of spite because we use Trello and no one else in the world uses Trello, and all the tools want to integrate with Jira. And Trello API is hell on earth. So I just wanted to do it, and I've done it. So that works. But I didn't do 1, 2, 3 because there are startups who can do it better than me. Instead, I started thinking, yes, we've imported ASVS into this database, and I'm sort of glossed over how we imported it. It was reasonably easy, but it wasn't a one-click thing. And ASVS is an active project. It develops, it adds requirements. V5 is coming, which is a big change, and maybe even V4 will have new versions. And I don't want to not struggle, but I don't want to do extra work when there is a new version. I want something really simple. So now it's time to talk how we imported things and how we can automate this when new versions come. So one thing you can do is to use data importer. Here's the URL. What you need is you need to export the WASP documents to CSV, and then you map them to your graph properties, and you click import button, and it happens. The pros of this approach is you have a full control over your graph structure. You create it here with this little visual editor. You map CSV columns to properties, full control, fully deterministic. You run it, you get the same graph every time. The cons are you need to turn this document to CSV, or you need to wait for someone to do it. What if they make mistakes? So still not fully automated. Another option is you can use LLM Knowledge Graph Builder. Again, here's the URL. You put your file here, you can point it to network resources if you have internet connection. It parses your documents, it builds you the graph, and immediately it gives you a chatbot to interact with the graph, so you don't even need to build an app. So what are the pros of this approach? It's sexy. What are the cons of this approach? It costs money, not to you, it's free, but to our company. But seriously, the cons of this approach is you don't have a full control over the graphs that it builds for you from your documents. It's pretty smart, it does a good job. You can help it, you can give it hints on schema, you can deduplicate, but still it's not fully deterministic and you don't get full control. The third method is kind of halfway. You can use this library, which is constantly updated, fresh release, and it's pretty awesome. You can build your graph programmatically from any data sources that you want. So these are the approaches for importing whatever you need to your graph database. So I've done that. When I started doing it, again, I read a bit more because in this field, every time there are new approaches, new architectures, new ideas. So this is what everyone was talking about. Like instead of Wikipedia, put any text, break it into chunks, calculate your vector indexes, and same as before. But something here wasn't sitting right with me because we already know ASVS is a very structured data. We have structure. Why would I break it into random chunks? It feels like I'm losing some signal here. So I've done some more reading and then came across these two papers, which were really, really light bulb moment for me. And as I said, I'm not a data scientist, but I could just about follow what Irene is talking about. And the concept that came up is ontological fishbone. So ontology is a structure of a domain. And yeah, ontological fishbone is subject matter experts can identify critical entities and relationships within a domain, and you can use this foundation to build a knowledge graph. But guess what? We already know the ontological fishbone of ASVS. We've done it, right? It has multiple chapters, chapters have sections, sections have requirements. So that's ontological fishbone. So same as before, but now I get to feel much better because it's not just something I intuitively decided. I am now a domain expert who built ontological fishbone. So it feels better. And this is the next version. I took V5 now. It looks very, very similar to the previous version, but a couple of important differences. Embedding, which is a long list of floating point numbers, is now a property of a node rather than a separate node. It's not terribly important on a small data set, but on a large data set, it's more efficient in terms of memory and speed of retrieval. Now, not only requirements, but chapters and sections have embeddings on the useful pieces of text in them. So you have more retrieval options. I tried a different embedding model. It didn't work as well as the previous one, so I went back to the previous one. And also this database, like if in this GitHub you go to the ASVS v5 branch, this database now comes with full text indexes in addition to the vector index. So it gives you much more options for retrieval, for experimenting what gives better results. And I won't bravely try another demo. So So chapter also have useful text, control objectives, and sections have useful text, description. And obviously requirements are still the most important bit. So it's mapped to CWEs. This is the long list of numbers I said. This one doesn't have NIST reference. And requirements have levels. So 3 levels that I mentioned. Right, resolution went to hell. I don't know why. I guess it's not fully loaded or something. So what can we do with this representation? We can try to filter on levels. So let's say if I filter on level 3 requirements, nothing changed, unsurprisingly, because on level 3, if you have an app that needs maximum security, not surprisingly, you need all the requirements. So let's try to filter on something else. Let's try level 2. And some nodes went gray. Let's see why. Because, unsurprisingly, that's a level 3 requirements. We don't need it if our application is level 2. Okay. So what's behind the scenes? What is this retrieval and why we talk about RAG and why we talk about graph RAG? What's the difference? So this snippet is in the language called Cypher. Cypher is like a sequel of graph databases for getting data out of graph databases. It's pretty easy to pick up, but if you don't want to pick it up, there are plugins that do text to Cypher. Let's figure out what's going on here. So I'm starting with the specific requirements 921. Step 2 is give me 10 most semantically similar requirements above a certain threshold, above 0.8. So that's just RAG so far, nothing graphy about it. What do I gain from putting this data into graph database specifically? That's steps 3 and 4. Now, if you think about the tree I've described, we start with requirement 291. How do I get to requirements in the same section? How do I get to 295? I need to do one hop up from requirement to section and one hop down within the same section. So if to get from one requirement to another, I needed 2 hops, they are in the same section. How do I get from 291 to something in the same chapter? How do I get from 291 to 275? I need from requirement to section, from section to chapter, and then 2 downs, 4 hops. If I needed 2 hops, I know they're in the same section. If I needed 4, I know they're in the same chapter. If I needed more than 4, then I know they are more distantly related and I want to give the similarity less weight. So I'm rearranging my semantic similarity, taking into account graph structure, how close they are in the graph. And I'm reordering them by this weighted proximity. So this is a really simple example of graph RAG. As I said, you have full text indexes. You can combine them with vector indexes. You have embeddings not only on requirements, you have embeddings on sections and chapters, much more to play with. So this is a little Cypher retrieval. I see much more complex ones. So a lot to play with and see what gives better results. So these papers are about graph RAG, as I said. It's about taking advantage of the structure. So the journey we've done so far only covers the first paper, using fixed entity architecture. What we've built, this ASVS tree, is fixed entity architecture. The second paper talks about expanding it, building extra layers on top of this ontological fishbone. And how to do it, you take any source of information. If it's structured, do something similar. If it's not structured, chunk it. calculate semantic similarity, connect everything to everything. What can we do with it? We can take other of us projects, for example, proactive controls or OWASP cheat sheets or any other piece of security relevant to web applications. It doesn't have to be open source. It can be your internal security standards, for example. You can put them on another layer of this graph and tie them to ASVS requirements. So we have a knowledge base built from reliable data on top of fixed structure, ASVS requirements. We can have powerful RAG algorithms combining different indexes and graph properties of this data. And when we give this contextual, reliable data to LLMs, it will turn it to a nice human-friendly answer that essentially will still give developers a small set of requirements that are relevant to their situation, to the feature, and to the stage of the development. Now, is it as good as sitting with your senior developer, with your security champion, and going manually and figuring applicability? Probably not. But is it better than having no requirements? Yes, it's miles better than having absolutely no security requirements. And you give something very, very accessible. Drop a feature description. Don't even write it specifically. Get it from your card. You get top 5-10 requirements that are relevant to your feature. To me, it's a win. And also, it's an easy entry point. People can read more. They can engage with ASVS more. They can talk to other people. What requirements did you get? It sort of lifts the whole security culture in your development teams. So this next bit looks sort of at the limits of my skills. I know there are people here who are real data scientists and really can do it justice. So maybe next time you present where you took this idea and we can find out what data sources you added on top of this fixed architecture. So that's my story so far. Any questions?